Welcome back, it's episode 180. Last week in AI, yeah, the news is never shady. Ideogram virtual drawing visions, not just maybe. Dream Machine 1.5, can't deny it's getting crazy.
Hello and welcome to the Last Week in AI podcast, where you can hear us chat about what's going on with AI. As usual, we will summarize and discuss some of last week's most interesting AI news in this episode. And as usual, you can also go to lastweekin.ai for articles we did not cover. That's our text roundup that also goes out on a weekly basis. I'm one of your hosts, Andrei Kurenkov. My background is that I finished a PhD at Stanford, and I now work at a generative AI startup.
And hey guys, I'm your other host, Jeremy Harris. I'm the co-founder of Gladstone AI, which is an AI national security company. And yeah, we're recording it. We're recording this on Monday. Normally we recorded it on Friday. This Friday, my body decided to start throwing up. And so, just thought that wouldn't make great content for you guys.
We try to avoid that kind of content. We try to be mostly about AI. So got a bit extra news. And if this one comes out a bit late, okay, this time it's Jeremy's fault. And speaking of Jeremy, last week in the previous episode, you said you're not the best part of a podcast. But if we head on over to listener comments and reviews, one of the reviews had some great feedback. Adam TW from Poland had this review that said, "Great Jeremy Harris plus subpar rest." So, Jeremy, you're great. This one, I appreciate the review. It points out to some I had some things I misstated in episode 177 regarding licenses. And I think I did accidentally say that Adobe was trying to acquire Canva when I meant that they were trying to acquire Figma. Some slip-ups. So thank you for the correction. Although...
No, sorry. I was going to say, though, it's funny because I feel like this is the yin yang podcast. We have so many commenters who feel very strongly about like one thing or another. There's like literally another comment that's like, yo, stop talking about the stupid safety stuff, man.
I know. That's another needs us to more research analysis. It's like the never-ending back and forth in our reviews. So we'll try to do a bit of both. And yes, thank you for corrections. Sometimes we do say things are incorrect. Although this reviewer, I will say, points out that Midjourney had a web interface for months, which I also said on that episode. So, I mean, we all make mistakes, reviewer, okay? It happens. And then another comment from YouTube. There was a request for us to kind of say again the title of a given paper, so you can go look it up once we discuss it. FYI, we do have the titles in the episode description, and if you go to last week in AI.com, you can also get the links to every single news story, every single research paper, article, etc. So yeah, if you found something interesting, you don't remember what it was called, you want to dig in more, go to lastweekinai.com and you can get all those links and everything. Alrighty, well, as always, thank you for reviews, both the positive and the negative. I guess as long as people are talking about us, we feel good. But moving on.
That's how that works. That's how that works. I love reading like, Jeremy Harris guy's such a piece of shit. If I could just kick him in the face, But
hey, we're still talking about me, so.
That's right. That's what matters.
Moving on to the news, starting with tools and apps. And the first story is about Ideogram and how Ideogram AI is expanding its features with its version 2 model and some extra options. So Ideogram is one of the players in the space for text-to-image generation. They've been around for a while, in a similar space to Midjourney, to Stability. Their big selling point initially was that they were able to handle text and images really nicely. And they could do, rendering of, let's say you want to have a card that says happy birthday. They could do that at a time when most these image generators could not. Now all the image generators can do it. So that's not so much a differentiator, but they now have an updated model that has better quality, as you might expect, even better handling of complex text blocks. So if you need a whole bunch of text, and there's also different types of models. So you can choose general, realistic, design, anime in 3D with different kinds of outputs optimized for different kinds of images. So yeah, I think it's interesting to see the space kind of maturing in a way, right? There's been a while, like 2 years now. Text to image, got going seriously early 2022 when OpenAI released the initial DALL-E 1. Then over the course of 2022, very rapidly it improved with VQGAN and Clip. By the end of 2022, we were generating really nice looking images. And last year, it got to the point where you could actually have basically photorealistic images. You could not tell them apart. Hands got solved, text got solved, all these like simple things got solved. This year, yeah, they're just becoming mature products, it seems like.
Yeah, that really does seem to be the case. Like we're long gone of the days of avocado armchair or whatever the prompt was from DALL-E 1.
The mind-blowing, the first thing you saw in the OpenAI blog post, avocado armchair, and it did blow my mind.
I totally agree, right? At the time, we all kind of got used to it, but there it is. And then one of the big differentiators, or the differentiator, I should say, that Ideogram is bringing to the table here is a feature called prompt magic. Basically, when you prompt the tool with something, it'll rewrite your prompt to get better results. And I find that really interesting. What is that meta prompt that rewrites your prompt? That would be really interesting from a prompt engineering standpoint, because it suggests they, understood something deep about prompt engineering. Obviously, other text to image models are doing the same thing in the back end. There's a question of how much visibility you get and how much control you get on that tool, but that's kind of cool. Another thing that's part of the rollout here is the color palette. So this is something, when you're a graphic designer or you're just a startup founder, you're trying to throw together a website and a bunch of assets, image assets really quickly, you often do want like a color palette. And that has been something that historically I found frustrating with other kind of image generation services, because you do need to match kind of your brand, your color palette. So here you go. You can control that sort of manually, which is kind of exciting, and applies to the style level as well. And they've got a whole bunch of other little features they're rolling out, search functionality, so you can actually look through public kind of data sets of Ideogram images. So you can search through pre-generated images. They've got apparently over 1 billion now. So they've got a nice search functionality that they're rolling out as well. So as you said, it's almost like everything but the model now. You're trying to make it a product, make the latency nice and low, give you all the affordances, the tools you need to tailor your output in the way you need it. So there we go. Ideogram off to the races.
Next up, another story about image generation. And the story is that Google releases powerful AI image generator you can use for free. So this is talking about Imagen 3, which we've covered on and off a while ago. They announced it, had images, it had the write-up, the paper for it we covered last episode. Well, now you can actually use it through their AI Test Kitchen service. So apparently, I forgot this exists, but I guess Google does have an AI test kitchen where you can play around with different models that they are working on and some of the research output that they have. So there you go. Now you can play around with Imagen 3 for free. And as with any text-to-image model, Imagen 3, really good. Google was one of the early players in the space with Imagen. They kind of showcased some pretty significant improvements in image generation, just going end-to-end, one big transformer. So if you want to play around with it, you can.
Yeah, this is your sort of standard issue rollout, maybe with the exception of the fact that it's free. And I'm not sure what the usage caps are going to be on this. Presumably there are going to be usage caps. But yeah, 30 seconds of latency, which is about par. It's pretty decent, especially for a free product. All part of that race to the bottom on pricing that we're seeing. We keep asking, well, how cheap can we make image generation? Well, the answer now is $0. So at this rate, by next week, we should be getting paid for using these services. But let's see if that happens. There's a whole bunch of sort of uncertainty around the data that was used to train this. So this is basically like every single release like this that we've seen. Where's the data come from? Won't tell you. We'll just tell you that the model was, quotes, trained on a large data set comprising images, text, and associated annotations. So, probably probably, one would guess, copyrighted photos in there. And there is, of course, a bunch of sort of safety wrapping around this, preventing you from like generating the sort of Grok 2 style, Kamala Harris and Donald Trump holding hands type stuff. You can't do that. Apparently, workarounds, basically jailbreaks, do work here. So basically all the standard things are still true for this model, except, hey, it's free.
Right. And on that note of restrictions, The Verge covered this. And it's funny with this and with pretty much every other tool, right? They might say you can't generate copyrighted characters, but you can definitely get around to it. So for instance, for Sonic, which if you don't know is the video game character that is a hedgehog, if you say an image of a cartoonish blue hedgehog running in a field, you're going to get Sonic. Okay. If you're going to ask for like an Italian plumber who is gathering mushrooms in a magic kingdom, you're probably going to get Mario. So even though Grok, you can just go wild and just get whatever you want, that's still sort of a case with even these types of models.
Yeah, which I feel like, especially when you have a model that's not being sort of like open sourced, it's still wrapped, right? You would imagine that you could have secondary kind of models reviewing the output before it goes to you to confirm, oh yeah, like, even if you do the Peach Magic Kingdom Big Bowser thing without saying the word Mario, you'd imagine you could actually have pretty good models reviewing that image and going, oh my God, no, like that does contain copyrighted material or characters that are readily identifiable with Mario. Let's not send it to the user. So that's kind of an interesting sort of omission in and of itself. Presumably expensive to do. Obviously, you've got more compute you got to spend on that, but it makes you wonder a bit.
Yeah, I'm sure the terms of service are very restrictive in terms of what you can do with these images. At the lightning round, one more story about image generation. This time we are going back to Flux 0.1. So the story this time is that Perplexity has added Flux to their tool for pro users. So Perplexity, if you're a pro user, there is an interface for doing image generation in Playground, and they allow you to, for instance, use DALL-E and Stable Diffusion for image generation. Now you can also use Flux version 1. And this is interesting because, to my knowledge, the first time people could use Flux was via Grok 2. Like the rollout of the image generation on X was via Flux. But it seems that they are pretty rapidly expanding that availability to other providers, other services. So now you don't have to use Flux via Grok. You can use it via Perplexity.
Yeah, and Perplexity like really shipping like crazy. We've got another article we'll talk about that features them in a minute, but just like a lot of really impressive rollouts. They also have this advantage of being a kind of I was gonna say a meta platform, not in the capital M meta, but they let you do a lot of things. And when it comes to images, they have a whole bunch of different models that you have the option to choose between. Flux 1 is now one of them, but they also allow you to work with Stable Diffusion XL, DALL-E 3, Playground V3. So, they're definitely giving their users a lot of options and not just kind of locked in on Flux.
Double checking, I was curious actually where you would use this within Perplexity. So it looks like, at least partially, you can use this for the whole publishing aspect of Perplexity, where they have this whole thing of create a page from a search. Well, that has like a banner at the top of here's the header image, so to speak, and that can be AI generated. So you can choose a style, describe it, and then one of these image generators creates it for you. So that is at least one place where you can use image generation with Perplexity. And Perplexity, for context, is mostly a search engine, so kind of an indirect way to use image generation. Moving on away from images to video, and the news here is that Luma has dropped Dream Machine 1.5. This is Luma Labs, and they kind of got pretty big. Just a few months ago, they came out with a Dream Machine and people started playing around with it. And it was, probably the front runner out there as far as tools you can use for free and kind of starting to approach that Sora quality we saw at the beginning of the year from OpenAI, but not quite there yet. Well, now with version 1.5, Of course, the quality is better. Now this model can also generate legible text, and it is significantly faster. It can generate 5 seconds of video in about 2 minutes, on top of being more realistic, having better motion quality, character consistency, all of that kind of stuff. So part of the big trends of this year, we saw text to video start to become a thing earlier this year. We saw actual text to video tools start to come out just a few months ago, Runway and Luma, and now they're at the phase of rapidly improving with new releases.
Yeah. This is a really interesting thing. Anytime you start to see that generation time creep down, 5 seconds of video in about 2 minutes, maybe, I don't know what that is, about, I guess, around 5% of the speed that it takes to actually watch the video. Some really interesting things are going to happen once we get that down to 1 second of video per second watched. You get into this world where you're streaming, basically. I mean, it's kind of what happened with YouTube, right? Like, you think back to those days and how the product fundamentally changed when we got into the era where we could stream as fast as we could watch. And that's kind of where we're headed today, right? This is just a hardware play. Like, make no mistake, this is just hardware optimization. We're going to get there for free thanks to like Moore's law and design improvements. And so, I think this is a definite kind of slow and steady march in that direction. A lot of new user experiences are going to pop out of that. But yeah, big changes here. Just level of realism seems incremental rather than, kind of revolutionary, let's say. But yeah, pretty impressive. If you just look at the results, there's a lot of consistency across the board from frame to frame. They talk about character level consistency being quite high. That's historically been something like the hands, right? If you think back to images, the hands that would kind of be a little bit weird, the quick tells that this thing is AI generated. Well, here it's like, how consistently does that tiger look, right? From one frame to the next, they got a tiger kind of walking around in a snowy landscape on their in the article. So anyway, sort of same idea. You've got these telltale tells that reveal these little glitches. The consistency, the what would you call it in movies? Like continuity errors, basically. Right. So those are, you can see it in this tiger example. There's a bit of a flicker. Like, if you look at the front 2 legs, it's very subtle. But expect to see that, show up less and less as we move our way towards this very high fidelity video generation.
Yeah. In the tiger example, it has a sort of characteristic AI thing of almost like tripping out, where as it's moving its legs, the left leg becomes the right leg, kind of thing, right? So that still happens, but it is going to be resolved. And for our YouTube watchers, I'm going to actually try and do some work this week and include some images and videos in the video version. Ooh. So you don't have to imagine it. So audio listeners, just so you know, you might be missing out on a few extra things there. And speaking of video generation becoming faster, the next story is also about that. And that is that Runway's Gen 3 Alpha Turbo is here. It can make AI videos faster than you can type. So this was previewed, and now it is officially released to users of Runway. And this version is 7 times faster and half the cost of Gen 3 Alpha. So regular Gen 3 Alpha is priced at 10 credits per second versus this is 5 credits per second. And you can buy 1,000 credits for about $10. And there's other kinds of discounts. You can also get them as part of annual subscriptions, etc. So that's 1,000 credits gets you 200 seconds. Right. So it's about, a few minutes per couple of dollars. Not cheap still, if you're like in audio production, whatever, but getting cheaper and getting a lot faster as well. So another example of that pattern. And Gen 3 Alpha, when it came out, it was already pretty impressive, already similar in quality to Luma, I will say. And this is continuing that trend as well.
Yeah, I think what we're going to start to see is this sort of trade-off between, resolution and performance versus speed of generation. Because there is going to be, it's going to be a big deal when we do get to that first 1 second per second. Right now, this is about 10 seconds of video generated in 30 seconds with whatever hardware setup they have in the back end, right? So remember, this is always hardware dependent. Runway has a certain amount of GPU resource allocated for this. They could increase that theoretically if they can parallelize more. But for now, given the hardware they can afford to throw at these price points, it's 10 seconds per 30 seconds. So sort of 3-to-1 ratio, pretty impressive. And, the early videos, as you said, the quality isn't 100%, but all these things tend to, kind of improve in tandem. So, really interesting to see this race unfold in real time, because I think this feels about the same pace actually as image generation, which itself is sort of interesting, right? It took about a year for it to go from, you can generate this in private labs, kind of really impressive private models, to it's open source, like you can do whatever you want for basically free. Really interesting world we're going to be in when that's true of video.
And one last story for the section. It is that Perplexity's latest update improves the code interpreter. So I guess this is a bit of a niche specific aspect of Perplexity, but it's still kind of neat and ties into what a lot of these tools do. So the update here is that its code interpreter, which is something that, to answer a query can run some code at real time. Now it can install libraries and display charts. So if you ask it for something like, over the last 10 years, what has been the trend about the rat population in New York or something, it could now run some Python to parse a CSV and produce a chart. And this is also something that, for instance, Claude can do, and I believe OpenAI can also do. So another kind of interesting pattern is a lot of these tools converging on a similar set of features and a similar set of functionality, where all of them have a code interpreter, all of them have, live previews. It seems like a lot of them will have artifacts, things you can publish. As you said, evolving pretty rapidly.
Yeah, I mean, the interesting thing here is, when you think about Perplexity's place in the market, right? It's not necessarily, although it does compete obviously with Anthropic, with OpenAI and ChatGPT, it's not necessarily thought of in those terms usually, right? It is framed and explicitly trying to compete with Google on the search engine side of things. What's interesting is that because they've done this kind of generative AI framing for the search problem, they're able to roll in a much more natural way these sorts of features, right? Like generating charts and tables and doing data analysis, not the sort of thing you would be in the mindset for when you go to Google. Usually it's this sort of high intentionality specific search. You're not necessarily planning on engaging in let's say, a high degree of investment in that interaction in the same way you have to with Perplexity, because you've got this prompting back and forth thing going on. So that's kind of an interesting play that is more natural for Perplexity as a value add than for Google. And that's, I got to think, a structural advantage, a mindshare advantage for them. This is something that Google would, if they were to do this, it would be a different product. They would have to charge for it because the compute costs would just be too high at this stage. And so I think it's just a very interesting positioning for Perplexity right now. They're going after the Google market, but at the same time, they manage to kind of effortlessly weave in a lot of these features that do involve more psychological kind of time commitment, effort commitment on behalf of the user, because their users presumably are more engaged, right? They're looking for an interaction. And I'm curious what that implies in the long run too about, these sort of the intentionality of search and how likely people are to click on links and stuff like that, because it is a psychologically distinct state from just at least your standard vanilla Google search.
Right. And it also makes me wonder to what extent is this going to compete not just with Google, but also with ChatGPT and Claude, right? Because as soon as this is essentially saying for any question, like with Claude, with ChatGPT, you can do a lot of stuff, right? You can, for instance, write emails, provide feedback, etc. This is saying for any information retrieval or question answering content, Perplexity can do that, and maybe better than ChatGPT or Claude, which is a huge proportion of what you would use it for. And you can also tell it, write me an essay on X and Y, and it will do a Google search and so on. So I think it'll also be interesting to see how that shakes out in terms of, do people go to Perplexity? Does Perplexity use ChatGPT as a backend? It's interesting. On to applications and business. And if you're doing your last week in AI bingo, go ahead and cross off hardware in the card, because we are starting with the story that AMD is buying server maker ZT Systems for $4.9 billion. as chipmakers strengthen AI capabilities. So this is part of AMD's ongoing efforts to compete with Nvidia. It sounds like this server manufacturer is going to make it so they can be more competitive in the space of, what a lot of companies are trying to ramp up on, which is AI kind of warehouses, right? Lots of servers to do training and inference and so on. So it will be part of the AMD data centers solutions business groups once it is fully united into it. And it sounds like people are happy. The shares of AMD rose by 3%.
Yeah, this is a really big deal acquisition. So for context, AMD's entire market cap, at least as of today, is around like $250 billion, something like that. And so if you look at them spending, so market cap, by the way, is not real money, right? That's just like how many shares of this company are floating around and what's the price per share that the market's assigned. That's not money that AMD like has in some vault somewhere. They have way, way less, right? And so when they're spending $5 billion, that's going to be a big chunk, of their acquisition budget for the whole year, and a big chunk of many of their other expenses. So this is a really, really big deal. It suggests a big strategic move from AMD in the direction of setting up servers, right? So AMD historically has been a competitor to Nvidia in a more, let's say, direct sense. So what they tend to specialize in is like, we're going to design a better GPU than Nvidia. And from time to time, they actually have, right? The interesting thing about AMD is they can actually make a better designed GPU than Nvidia and still lose on sales to Nvidia just because Nvidia goes out and buys out all the fabrication capacity at TSMC. So AMD basically can't get anybody to build their wonderful designs. That's one strategy that Nvidia has used in the past. Not that they don't also design wicked good GPUs, they do. When you look at moving as AMD now is trying to do with this ZT Systems acquisition, they're trying to move into the server market. And servers include a lot of stuff besides just GPUs. It's not just a bunch of GPUs sitting next to each other, right? You need storage, like longer term stable storage, like SSD. You need networking interfaces, power supplies, cooling systems, that sort of thing. So there's a lot going on there. And this is an attempt to move in that direction, which is a play at that, AI training market and all that stuff in a broader sense. There's been a lot of debate about the antitrust side of big acquisitions like this, especially in this space. The Biden administration has been looking really, really closely. Other administrations have been as well in other countries, but specifically in the States. One of the things that AMD is doing here is, they're going to acquire ZT Systems, but they're going to offload their manufacturing arm. They're basically saying, hey, the whole part of the whole part of ZT's like company that does manufacturing, we're getting rid of that. And the reason there is partly just to kind of streamline things, but also it allows them to focus on the higher margin AI infrastructure and software part of the business, and free up resources. It might also kind of make it harder to claim that there's some kind of kind of anti-competitive thing going on here where you're taking over too much of the market, whatever. AMD is still pretty small relative to Nvidia, so I suspect that wouldn't be an issue, but it's got to be on everybody's minds, especially with acquisitions this big. So a lot of interesting things going on here, a lot of things to try to avoid the kind of regulatory call out of like, oh, this is like a market capture play. They've set up a deal so it's a mix of stock and cash, and that as well can be a bit of a signal to regulators just to say that, hey, this acquisition is not just about kind of asset consolidation. It's also about a partnership. So we're both going to take some risk here. It's, equity is involved. So anyway, that's the big plan there. And it's going to be interesting. We'll see if it makes a difference. As you said, the market is responding, stocks up 3% for whatever the hell that's worth these days. People seem to think it's going to go somewhere. So somewhat unusual, by the way. Usually post-acquisition, at least quite often, you'll see the stock dip because most acquisitions turn out to be flops. So we'll see. This one seems structurally interesting for AMD.
And now to a lightning round, we begin with a story that Ars Technica content is now available in OpenAI services. This was published by Ars Technica, And this is because of OpenAI's partnership with Condé Nast, which is one of these brands that publishes content. So we've already talked many times about OpenAI making such deals with other publishers, The Atlantic, Associated Press, Axel Springer, etc. And this is a fairly detailed article from Ars Technica going into what this means. It means that, for instance, you will be able to see content from Ars Technica. If you ask it, what is this latest story on Ars Technica, or what does Ars Technica say about OpenAI, it can now create that content. And they also can crawl the content of Ars Technica for training purposes, which is a big contentious issue. And in fact, just a month ago, Condé Nast sent a cease and desist order to Perplexity AI over data scraping. So this is, a kind of interesting timing of, we just saw the same company telling another company to, go away, don't look at our data. And now they have announced a partnership with OpenAI.
Yeah, I'm so structurally fascinated by this particular play because one of the things that we run into a lot when we talk to folks on the Hill is a very understandable concern that if you're going to bring in AI regulation, you might end up essentially anointing winners and losers, right? You might have some regulatory capture going on. Well, what do you make of a situation like this where essentially OpenAI is setting a norm of saying, hey, you got to be able to put up multi-million dollars to sign these big deals individually with a whole bunch of publishers in order to be able to use their data for training, in order to serve their data up when people ask a query to the model? If that's not lining you up for some kind of crazy moat, I mean, forget then about, little actors popping up and saying, oh, I'd love to have, links from the Atlantic or whatever, the Associated Press featured on my website or through my app. This is just an absolute kneecapping if anybody wants to compete on that level with these kinds of products. So that I find really interesting from regulatory capture standpoint. I mean, this is essentially a moat made of pure cash, and OpenAI certainly has it to spare. So kind of an interesting thing. Yeah, Condé Nast, latest thing to fall in line here. We've got a whole bunch of these publishing houses and newspaper outlets that now are kind of on that side of things. It also kind of makes you wonder a little bit about the editorial stance of these firms when it comes to precisely this kind of question, right? There are open questions about the ethics of having one lab or another having to pay or not pay for licenses to access content, blah, blah. And this is playing out in the press. So, to the extent that trying to shape the public narrative around this is important for companies like OpenAI, you might expect, these sorts of deals to do a lot of the talking now for you, because you've got to essentially capture such a large part of the media world. So I think it's just really interesting for the incentives that it tees up. And hopefully we'll have a nice, robust public debate about where this all goes and whether it's good.
Right. And I think we've touched on this also, but it's interesting in the sense that OpenAI is doing this really, I would think, impressive acrobatic move where, a year ago, they were like, oh, it's free use. We just used all your data for training because it's free use and it's okay. Everyone should be able to use data to train AI models. And now we're like, well, yes, it's free use, but also we're going to pay you to use the data too, because what if it's not for use, I guess.
Yeah. Well,
which is it?
Conspicuously absent, one will note, listening to all this stuff, is any reference to the same idea, the same principle applying to video. Gee, I wonder why that is. Gee, I wonder if it's at all related to the fact that YouTube is a giant cavernous pile of video data that OpenAI might love to scrape, and in fact, some have suggested almost certainly is scraping. You don't see OpenAI offering Google big bucks to use YouTube, as far as I've heard, at least. So it's sort of interesting. It's like, okay, we're having this really interesting, nuanced debate about, ethically you should have licenses to use Axel Springer's stuff, the Atlantic stuff. But what about video? Right. So I'm curious, are we going to see some kind of, in the same way that Google pays $20 billion a year, whatever it is, to Apple every year just to be on the iPhone as the default search engine? Does OpenAI end up forking over giant wads of cash to Google to build a product that ultimately directly competes with Google's products in a way that isn't quite the same between Apple and Google on that iPhone bit? So I think this is going to be really interesting. I agree with you. I think there's, let's say, room for paradox here, and OpenAI certainly seems to be embracing it. So we'll see what comes of this.
Next up, Anysphere, a GitHub Copilot rival, has raised 60 million Series A at 400 million valuation. So this is a startup that is developing the AI-powered coding assistant Cursor. And as per the title, they raised a pretty substantial Series A at 400 million post-money valuation from some big name VCs, A16Z, of course, Thrive Capital, and the co-founder and CEO of Stripe, among others. They have previously raised an 11 million seed round with some other famous investors. And it kind of makes sense, I think, that they're getting this investment. GitHub Copilot, to this day, is still one of the only examples of very profitable AI products. I think, like this article says, an estimated 3 million developers worldwide are paying Microsoft $100 a year to use Copilot. And so you can easily see how you might want to compete and why people might want to be funding a competitor.
Yeah, no, and you're absolutely right. And it really seems to be the OpenAI, broadly OpenAI affiliated suite of products that has been doing best on the monetization end. Like, you think about, we've looked at, posts that talk about how OpenAI is generating whatever it is, 3 billion or so of annualized revenue. And if you look at basically all the other revenue in the generative AI space, it is not that much more. So, hard to make money in this space. If you're going to compete, you got to do something like Perplexity. You got to take on something that, works pretty well and have your own twist on it. And that certainly is what's happening here. At least we haven't seen, that many new products, new classes, new categories of products in the space. I'm sure we will, by the way. But at least for now, the most profitable ones seem to be kind of twists on things that we've seen around for quite some time. Notably, that $11 million seed round, by the way, that they first raised was led by the OpenAI startup fund. And they say, interestingly, and I'm a bit confused about the language here. So led by OpenAI startup fund with participation from Nat Friedman, one of the Dropbox co-founders, so on. Usually you don't need like an explicit lead for a seed round. So I'm not too sure what that's about. But anyway, OpenAI startup fund is there, and expect them to keep showing up because they are having, they have a unique perspective on these up and coming startups. They can see, sort of like Stripe, by the way. Patrick Collinson, one of the co-founders of Stripe you mentioned, is one of the folks leading this round or involved in this round. If you're OpenAI, you are seeing the token consumption of these companies. You're basically getting an early sense of, okay, which companies are hot, which ones aren't, based on usage. And based on that, you can, just like Stripe, right? This is a payments company. They get to see how much money you're making. And that allows them to have a wicked effective investment arm. Well, OpenAI, same thing, to the extent that value is denominated in flops or in tokens increasingly in the world of AGI, OpenAI startup fund's position starts to look a little bit structured like Stripe's. And that's a really interesting proposition. And I wouldn't be surprised if that's reflected in, the sharpness of their early investment here. So, we'll probably see more OpenAI startup fund success stories before long.
And just one more thought on that topic. Also, 60 million, pretty big Series A still, even within the world of tech. It's pretty large. I will say we used to cover like 100, 200, 300 million
That's right.
rounds every week.
What happened to
every
$100 million threshold? Yeah.
So I think there's been a lot of talk, and we haven't really dived into it, but there's been kind of in the air a lot of thinking and talking about, are we in a sort of winter? Is the money drying up? Are people now starting to want, actual profits and revenue? And it does seem to maybe be the case. But if you're in a profitable sector that isn't as, I guess, long-term a bet, I do think there is still space for VCs to be excited, like with this company. Next up, Stability AI appoints new chief technology officer. So the new CTO here is Hanno Bass. This person has 30 years of experience as a CTO at companies like Digital Domain, which is a visual effects and digital production company. And this is, of course, following a tumultuous year for Stability AI, as we've covered. There was famously the, I don't know if you say oustment or the, let's say the CEO of Stability AI left at some point. And
the showing of the door.
Yeah. Anyway, the leadership, a lot of the technical leadership, as well as the CEO left. Seemingly because the company was a bit chaotic, didn't have a clear business plan. And so this is notable from a perspective of Stability AI still probably trying to turn the ship around, trying to become more of a business that makes money and doesn't just publish open source models. Here they have a very experienced, very kind of mature, seemingly business person at the helm. So I think that plays into that entire kind of journey they're on.
Yeah, I mean, I think, without wanting to try to mind read board machinations at Stability, like my guess is at this point, you're sitting on this company that's raised a just gigantic ton of capital, and they've burned through an awful lot of it. But at this point, if you're a board member, if you're an investor, you're just kind of thinking like, okay, how do we save this ball of capital? Like, it's so much sunk cost. The reaction often can be, oh, you need an industry veteran, a stable mind. It's complicated. It's hard to know whether this ends up being a good play, but it often is. It can be a mistake. It can be a mistake because you end up with a overly conservative player or somebody who doesn't bring the kind of fresh perspective you might need. It can also be a good play. In this case, he has previously, I think you might have mentioned Microsoft Azure Media and Entertainment. He was the CTO of that. He's done a whole bunch of stuff regarding Microsoft Azure's cloud technology. So that's, a lot of infrastructure work. And when you think about the sorts of things Stability really needs, right, they need to be able to run efficiently at scale. They need to drive down costs in a big way because they need to bring in profits. Like Stability is not going to raise another round unless they can show, that they have a strategic play and some profits. And to your point earlier, I think they're one of those companies where the question, where's the beef, is gonna start showing up awfully fast, given how much they raised, how fast they rose, and then how quickly they seem to have fallen. So hopefully he can turn the ship around, and we'll have more pseudo open source releases from Stability AI in the future.
We'll see. Yeah, he was also the CEO of Weta Digital, and at first my reaction was like, "Oh, this doesn't seem like a very AI-oriented person." But when again, if you're working in VFX, in special effects, a lot of overlap, surprisingly.
A lot of GPUs.
Yeah, exactly. And the last story for this section, one of my favorite topics, of course, it's robotaxis. And the story is that Cruise's robotaxis are coming to the Uber app in 2025. So Cruise has announced a multi-year partnership with Uber. And the claim is that once Cruise does relaunch the driverless service, they will be able to provide those through Uber as opposed to their own custom app. Just to recap, Cruise was actually serving customers in SF, just like Waymo was. You could hail a robotaxi. Then there was a major crash. There was a problem of communications with regulators, and Cruise has been in trouble ever since. So this seems to be probably pretty good news for Cruise to have that kind of platform to compete with Waymo against. And certainly between Tesla and Waymo and Cruise, next year will be a pretty big one for robotaxis.
Yeah, and it's also, this is a real callback to late 2020. Uber then sold, I'm old enough to remember Uber ATG, right, Andre? You might remember them, the sort of self-driving car unit of Uber. This whole idea of self-driving cars being linked to some service like Uber, it was often considered part of the strategic calculus, right? The idea was Uber was going to be the pioneer in self-driving cars. They'd get to own the whole stack. They would own the vehicles, the physical vehicles, and then they would also own the sort of coordinating marketplace infrastructure around it. Now, the fact that they're having to basically, have Waymo be the first self-driving cars on their service is, it's been 4 years, but I'm sure it still stings. This again was a very strategic play, and I remember talking about the prospect of Uber or Uber's prospects long term, and it really did seem like the hard thing was going to be getting the self-driving car capabilities online. And once you do that, you can just be so profitable. So much of the cost of a ride is the time of the driver. And so expect the economics around this stuff to shift quite quickly as you see these rollouts in more and more cities. But really interesting to see, and Uber hopefully will be able to make do with what they have here.
And on to projects and open source. We start with AI21 introducing the Jamba model family. So these are two new models, Jamba 1.5 mini and Jamba 1.5 large. Jamba is this interesting class of models because they are a hybrid of Transformer and Mamba. So they use the established model that is used in ChatGPT, Claude, etc., Transformer, that is really good, very performant, but has issues scaling. It costs more and more and computationally takes more and more as the input and output grow bigger. Mamba is one of these things we've been covering for probably a year now as an alternative to Transformers that is more of a recurrent architecture. So you can think of it as like it can scale infinitely. The longer the input, nothing really changes. And what you've seen for a while now is that it seems like combining the two together yields the best results. And so here they release these two models. The Jamba 1.5 large is a mixture of expert model with a total of 398 total parameters. And the claim from AI21 Labs is that these models are outperforming models of similar sizes, like Llama 3, 8 billion and 70 billion, right? Which would be a pretty big deal. So far, Mambas have been pretty promising, but the kind of challenge has been that they haven't been proven to really work at scale so much. And so there's been demonstrations of Mamba type models working at smaller scales. I'm pretty sure this Jamba 1.5 is the biggest hybrid model that's been released and shown to be very performant. So yeah, pretty significant steps here. And it does say that, especially on prompt lengths of 10,000 tokens and above, you get better performance, which is kind of what you would expect.
Yeah, I mean, this is the most scaled Mamba architecture I remember seeing, like architecture involving Mamba in almost any way. And I think it's really cool they made this choice. This has historically been one of the big questions, right? How does Mamba scale? Whether on its own or in a hybrid architecture with Transformer, like how does it scale? Can you really make it work? And, I was thinking about this, because we've explained Mamba in many different ways. And there was like one take on it that I thought might be useful. Just to kind of give people an intuition for why it could potentially be interesting, and then why it might combine so well with Transformers. And I'll just really quickly give it a shot. Like, if you have a Transformer, basically what you're able to do is look at how all the different words in your input are connected to each other, right? So if you feed, the model, 128,000 tokens of context, that's all it can fit in its context. It won't be able to fit more. But within that context, theoretically, it can look at connections between all those different words. And so really kind of, account for very complex relationships in that text, very complex and rich information. But you've got a maximum amount of data you can capture, a maximum context window size. The alternative with Mamba, one way to think about it, this is not exactly accurate, but just to build that intuition, it's almost like as the model, say, reads more from a piece of text, it's got a little scratch pad, and that scratch pad has a finite length. Maybe it's like 1,000 words. And it goes through and it keeps updating. On that scratch pad, it's writing a summary of all the stuff it's read so far. And you can imagine it basically going through and just like updating a word here, a word there, as it keeps reading a longer and longer document. And so no matter how long that document is, you can just keep tweaking what's on that scratch pad to make it reflect what you've previously read, right? So this has the advantage of meaning that you can read an arbitrarily long document, and you can keep just tweaking that scratch pad summary, that one-page summary that you've got, and then use that to inform, okay, what's my next word prediction? What's my output going to be? Now, so those two things are kind of in contrast to each other, right? The Mamba thing has a maximum memory capacity that's kind of going to where essentially it's got that scratch pad, it's not going to be able to account for all the kind of complexities of what it's read, right? It's going to forget a lot of that detail and only preserve that high level summary, but it works on arbitrarily long inputs. Whereas the transformer actually is going to account for all that little kind of detailed interaction between all those different tokens in the context, but it can't go beyond that context. And so that's really where you get into the combination of these two being very effective. It's a really interesting paper. They demonstrate, one of the cool things they demonstrate is, unlike other models that often claim to have really long context windows, in this case like 256,000 tokens for the longest context window they have in Jamba 1.5, often what you find is it's like, sure, your model has a long context window, but it can't actually use the information reliably within that context window. It'll forget stuff. And the needle in a haystack test that we've talked about before on the podcast is an often used metric of like, how often do you forget sort of little facts buried inside a giant context window? And they basically show that, like, unlike other models with long context windows, theirs actually can recall facts that are buried all across the context window. And so they use this ruler benchmark thing, which is basically needle in a haystack eval on steroids, to show that it actually can do that. Another thing they do, and just the last thing I'll mention, is they actually develop for the smaller model they use a special distinct quantization method. So quantization is when you take these models, normally, so model will have a whole crap ton of weights, these parameters contained within it that tell you how to mix the data that you're feeding to it. So each of those parameters, you're going to have to kind of give its value to a certain precision, a certain number of decimal points. And one quick way of making your model smaller is to quantize it by reducing the resolution, the precision of those representations, by storing these digits using, for example, in this case, 8-bit precision format. And what they do here is they only compress the experts in the MOE. So the kind of submodels that queries will get routed to, it's only in those submodels that they're actually going to do that compression, going to reduce the precision of the representation. And so that was kind of interesting. They call that experts int 8 instead of just the standard int 8 or integer 8, which is the 8-bit precision format way of quantizing things that people usually go with or often go with. So kind of interesting. Only applying it to the experts in the MOE model, that does account for 85% of the model weights for a typical MOE. And so, it works well. They can fit, even Jamba 1.5 large will fit on a single 8 GPU node. So basically, it'll fit on 8 GPUs together, and that's a pretty powerful thing. It does make it a lot more democratized, a lot more accessible, because this is a big model.
Yeah, it's kind of interesting looking at this ruler paper. It came out just early this month, 6th of August, 2024, and the title is "Ruler: What's the real context size of your long context language models?" So there you go. They say, there's the claimed context size. And for instance, with something like GPT-4, you might say that it can handle 128,000 tokens. But that's really like the upper range of what a model can handle architecturally, right? Versus how much can you actually use effectively is different. And so this benchmark can evaluate that better than anything we've seen before. And it's pretty fun. They do say that here, not only do we claim 256,000 context, and if we can do it, as opposed to something like Gemini 1.5 Pro, which claims like 2 million context length. And according to them, it's only 128K, although might be a bit bigger. It's hard to say from the paper. So exciting developments for sure. This is out with the Jamba Open Model License Agreement. Very similar to other kinds of agreements we've seen, where it says you must follow the acceptable use policy. You can't use a trademark. You must include a reference to this. If you train a model using data from this, you need to have Jamba in front of it. Things like that are kind of fun little features of licenses for AI models.
It's very Llama-y.
Exactly, very Llama-y. It seems like you can use this for both research and commercial purposes. So, effectively what we consider open source these days for models. Next, we have Phi 3.5 from Microsoft. So Microsoft has been on a tear with these Phi models. We've now gone up to 3.5, and this one is available in 3.8 billion, 4.15 billion, and 41.9 billion parameter versions. Pretty unique there for Microsoft to go with these sizes. And as with previous releases of Phi from Microsoft, this is very much meant to be a smaller model you can run locally on your own GPU, on your own computer even, and it is pretty performant for this class of models. So they say if you compare it to the other 3 billion, 4 billion parameter models, this will get you the best improvement, the best performance for that size. And you can also run it, of course, in a mixture of experts model. There's also a vision model version that can understand images, in addition to that mixture of experts model. So interesting to see also a bit of a trend, more and more vision language models becoming available for people to use.
Yeah, and two kind of things that are fairly distinct in this instance, at least. So Microsoft, the Phi series of models, one of the big differentiators that they have is data quality, right? Like they basically are overtraining these models, especially the small ones. That's often done. By overtraining, I mean that theoretically, if they took the same amount of compute that they're using to train these models, they actually they could get better performance if they increase the size of the model. Like the model size is actually a constraint, and they're intentionally clamping the model size specifically to make sure they end up with a small model that can perform really well. So in principle, like if you wanted to follow the scaling laws, you could create the world's best small model conceptually, very straightforwardly. Just pour way more compute and data at a fairly vanilla architecture, and you do quite well. Here, Microsoft is opting probably to do some of that, also to do a lot of careful data selection. That's been a big theme in their Phi model papers. And then another really interesting thing here is we're looking at with Phi 3.5 mini, right? This 3.8 billion parameter, really tiny model, 128,000 tokens of context window. That is way bigger than what you'll see with any other 3.8 billion or 4 billion parameter model. That is a really interesting option. It's helpful for edge device deployment, right? You only need room to store 3.8 billion parameters. So you can actually start thinking about putting those on edge devices. And now your edge device can function with a 128K token context window, which is quite impressive and interesting. So, a lot of cool stuff coming out the Phi series here. They're also announcing a special mixture of experts model, Phi 3.5 MOE. This is it's as you said, it's a bigger model for 42 billion parameters, over 20 languages that it supports. And anyway, they go into a little bit of the detail as to how they actually do the fine tuning and kind of dial the behavior in. But they do use DPO if you're a reinforcement learning from human feedback nerd. So DPO is there. That's a trend that we're seeing obviously more and more of. And there's a whole paper anyway on the safety fine tuning, and they have this break fix cycle that they implement internally. Bottom line is really interesting series of models. The Phi series is one of the ones that I'm watching most closely, especially for the kind of model miniaturization side. I think these are really cool.
And on that topic, we have one more story, and this is one from Nvidia. They have released the Llama 3.1 Munitron 4B, which is their own little small language model that improves upon Llama 3.1. So
the name actually takes up most of the context window.
Yeah, so the way they do this is they take the Llama 3.1 8 billion model, and then they apply what's called pruning and distillation. So pruning and distillation basically means you have a big model that's pretty good, but you can actually make it smaller while retaining its performance. And so they did that to the 8 billion version of Llama 3.1, reduced it down to 4 billion, and then did some extra fine-tuning on some extra data. Now it has been released on Hugging Face under the Nvidia open model license. So, it's another week, another couple small models for people to use that are better and better.
Yeah, I mean, I found this kind of interesting. So they're showing it's sort of unusual that you'll see this. Like they basically show that if you start with a bigger model and then you prune it, so basically get rid of, let's say, unnecessary weights, unnecessary neurons. So you can go, in this case, they go from 15 billion parameter initial model to an 8 billion parameter model. And then they're going to take that 8 billion parameter model and they're going to use its outputs to train a separate 4 billion parameter model to basically just like replicate what the 8 billion parameter model could do, and they repeat that process to get a smaller and smaller model. And what they find, at least with their 4 billion parameter model, they actually get a model that performs better than if they had trained that 4 billion parameter model from scratch, which is kind of interesting. So they have this 4 billion parameter model that it turns out is competing on par with like Mistral 7B, Gemma 7B, Llama 3 8B. So, pretty impressive. It's a 16% improvement on MMLU to the extent that you care about that deeply flawed benchmark. It's an interesting improvement. So yeah, another big step in the direction of like smaller models and processes that allow you to get there with fewer resources. And anyway, I just think it's a really cool space to track between this and the Phi models. People who are interested in model shrinkage have a lot to track this week.
That's a good point. This is all building on this paper we released a few months ago, Compact Language Models via Pruning and Knowledge Distillation. So pruning is a bit where you just get rid of weights you don't need, like pruning a tree. Knowledge distillation is that other bit where you have a large model and you get it to spit out some data and basically train the small model to match the big model, as opposed to just removing bits of it. So they did that technique to have their first Nematron family of LLMs going from 15 billion to 8 billion to 4 billion. And this story is how they basically reapplied that same technique to Llama 3.1, 8 billion. And one last story for this section. It is that open source Dracarys models ignite generative AI fired coding.
No copyright problems there.
That's some fun naming from VentureBeat on the article title. Dracarys is coming from Abacus AI, who have previously had other dragon-themed LLMs, I think, that we've covered. So here they have the Dracarys one that's optimized for coding. They took it to improve the coding abilities of other open source LLMs. They showcase this on both Qwen 2 72B and Llama 3.1 70B and release these models that are then optimized versions of this for coding. So I think if both of these stories, or all three of the previous stories, you're seeing a pattern of basically what happens in open source, or sort of actually the last two, Nvidia and this one, both took Llama and then improved it in different ways. In the previous one, it was via distillation, making it smaller. In this one, they have their own little recipe of getting some data. I don't think they've actually published a paper on it, but the point is that they are able to take models and improve them for certain applications like coding. So there you go. If you want to have a very good model for coding, there is now one open source for your use.
And coming up next, Jeremy's Weekend. That's actually what this was. So this is a paper that came out by Epic AI. And this is just a research company that does some amazing research on AI capabilities and trends forecasting. And they came out with a freaking juggernaut of a paper that I spent most of my Saturday reading and most of my Sunday rereading. So a couple of things. Basically, the title of it is, "Can AI Scaling Continue Through 2030?" Right. So we're seeing right now these trends towards scaling AI models. They're getting bigger and bigger and bigger. You're seeing in particular the amount of compute that's being thrown at training the leading AI models increase 4-fold every single year. For context, that is faster than any other technological kind of peak growth rate that we've seen in the last many decades. You think about mobile phone adoption, that was doubling every year. Solar energy capacity installation, 1.5x per year. Human genome sequencing, a notoriously fast acceleration at 3.3x a year. That is all less and significantly less than 4x per year, which we're seeing with compute budgets. So things are getting insane really fast. And the obvious question then is, how fast, or how long rather, can this be maintained? And essentially, do you crap out, right? Do you run out of resources to be able to continue scaling these systems before you get to very, very powerful AI systems? So I'll give you the headline here. And the headline is that their expectation, Epic AI's assessment, is you can probably continue the current scaling trajectory, that 4x year over year, all the way through to 2030 or so, by which time we will have systems that are 10,000 times more scaled than GPT-4. That is the same gap as between GPT-2, which most of you will never have heard of or interacted with, and GPT-4, which everybody has heard of and is powering autonomous agents and is covered on most episodes of this podcast in some form. So this has led a lot of people to speculate, and I think quite reasonably so, just based on at least what I'm hearing from inside the labs, their experiments and what we can see from, like AI scientists and other successful experiments like that. Like, it's plausible you could automate full-on AI research with that kind of leap. It's also plausible that scaling won't work, right? That you'll dump all this compute in and not get the kind of value that you need out. But that's I think quite plausible. The big question is, right, what is going to break when you start to scale this hard, this fast? What breaks? And they identify 4 different potential things that could break. One is power, right? It takes a huge amount of power to, power these gigantic training runs. And their expectation is you're going to need 1 to 5 gigawatts of power to train the 2030 level training runs that they expect to happen. For context, currently, the largest clusters you'll see are usually in the just over 100 megawatts of scale. So essentially you're looking at maybe 20, 30x beyond where we're at today for the kind of mainline expectation of what 2030 will bring in terms of power. Now, power is not compute. Right? It's not, we're going to be spending 20 to 30x the amount of power to train these models in 2030, they expect, but the actual amount of compute is going to be 10,000. So why that gap? Because you would naively think wait, isn't, one extra computation, one extra increment of power, shouldn't they scale together? And the expectation here is that these models will get, and the hardware in particular, will get a lot more power efficient, more energy efficient. And there are a whole bunch of other reasons why you might expect that stuff to scale weirdly, but it's all laid out in the report. So you got energy or power, then you've got chips. Will we run out of GPU production through 2030? And this is really interesting. They talk about a lot of the stuff we talk about on the podcast. What are the key bottlenecks to chip production, to GPU production? Well, guess what? It's not the actual logic. It's not the thing that does the number crunching on the chip. It's actually the packaging, right? So the ability to take all the chips that you need and kind of glue them together to make a GPU, kind of set them together on the same device. And that's CoWoS. That's this new packaging technique that's really rate limiting on this, and it's high bandwidth memory. So anyway, bottom line is chips and power turn out to be the kind of constraints that start kicking in first. It's not super clear which one kicks in first. I actually, before reading this report, I actually thought power was going to kick in sooner and significantly earlier than chips. Turns out there's a lot more uncertainty there. They kind of seem roughly tied. And then there's data. Will we run out of training data? And there are a whole bunch of open questions here, a lot of uncertainty there. You have a whole bunch of multimodal data, like video data, that could be used. Synthetic data is a big X factor that could increase data availability by a lot. Bottom line is the data wall gets hit plausibly somewhat later than 2030. And then the last bit is this thing called latency. So latency is really interesting. It's a kind of irreducible constraint on your ability to scale. So think about the amount of time that it takes for the input data that you feed your model to go all the way through to the end of your model and generate an output, right? That's going to take a certain amount of time. And the larger you make your model, the longer it's going to take for that information to propagate through the model and get processed, right? Well, if you're thinking of doing a training run, your training run is going to have to involve a whole bunch, no matter how you slice it, a whole bunch of these kind of these runs where you do forward and backward passes to train your model. You're going to have to feed your data and have it run through a whole bunch of times. And if you assume that, okay, these training runs can only last like a year or so, which is in practice the reality, because within a year, there's like a whole new generation of compute that's going to come out. The whole infrastructure you're using is going to get outdated. So you need your model to come off the production line pretty quick. So you have a year. It takes a minimum amount of time for your data to propagate through your model. And that does actually end up placing a hard boundary on the amount of compute that you can practically pour into a model based on its size. There's a whole bunch of detail in this paper. If you're a kind of AI scaling hardware nerd, especially if you're interested in the national security picture like me, take a look at this paper. This is just a wonderful, wonderful document. And if you're not, hopefully you appreciate the highlights.
Right. And it's hard to overstate how kind of useful this is in a sense, because scaling, as we have covered, is one of the major, like maybe the important trend in AI, and has been pretty much for a decade, but especially since 2020, when GPT-3 hit, it became very apparent that scaling laws are a thing. If you go from GPT-3 to GPT-4 with 10x the parameters, there are other things that matter, like alignment, like RLHF, but getting more data and getting bigger models is the main factor, seemingly, to progress, or at least one of the requirements. And this is a real question, right, of like, how much can we scale just due to physical constraints of the power required, the compute required, the data transfer required, these kinds of things. And this is pretty much doing that math and showing that it is insane, like the requirements needed to do 2 orders of magnitude above GPT-4. And that's, to be expected. GPT-4 already was far beyond what was even imaginable in training, in like a few years ago. GPT-3 was already unimaginably big when it came out in 2020. So this is saying that it is plausible that it would be possible, assuming hundreds of billions of dollars, if not trillions of dollars of investment, right, to get there. And that's, I think also this is covering also that data question in a pretty nuanced way, where they show uncertainty margins for each factor, saying, this is how certain you can be about where your limit is in terms of how far you can train. And so on the more, physics side of things, of power and compute, those are fairly low uncertainty margins, versus with data, those are quite high, because you don't know. Maybe synthetic data will be very useful, maybe multimodal data will be very useful, but it's hard to say. So this projection of 2030 is on the lower end, broadly speaking, of the uncertainty. So if it's somewhat conservative in terms of saying we're not going to be optimistic about data and synthetic data, not going to be optimistic about chip production necessarily, things like that. So yeah, very good kind of conclusion, or very useful conclusion. Not really touching on the question of, do the scaling laws we see empirically so far, are they going to continue as we scale up another 2 orders of magnitude? I think the current hypothesis implicitly for most people is yes. We'll just see the same trend of improving performance as you continue to scale. It's not going to plateau as some things plateau, but that remains to be seen.
Yeah, and what does it mean, right? So for context, like the scaling laws, right? They tell us, roughly speaking, as I increase the amount of compute and data that I feed to my model, how does its next word prediction accuracy improve, right? And what you learn is that there's a power law there, and that as you increase those things, you do get a reliable, predictable increase in next word prediction accuracy empirically, or at least you have. There's a separate question as to what that next word prediction accuracy actually buys you in terms of capabilities. And this is really where so much of the debate is focused. Most people, as you said, Andre, buy into, probably these scaling laws are going to hold. They're actually, they're almost as well established as many physical laws were when they were first called physical laws. You can think here about things like, empirical laws like the ideal gas law, things like this. We've seen it apply across like 10 orders of magnitude now, that's a pretty well-established trend. It doesn't mean that it'll hold indefinitely, but a lot of people, including companies like Microsoft, we've talked about this, right? I mean, the amounts, the scales of these build-outs, both in terms of energy and chip usage, seem absurd, but so too is the investment that is happening today by companies like Microsoft. Talked about how Microsoft is engaged in what may be the single largest infrastructure build out in the history of the human civilization, $50 billion per year on these data centers, on the thesis that it's going to lead to something like AGI. That's kind of where that's coming from. This is like in 4 years, that's $200 billion. That's the Apollo moon landing, right? For scale. So this is a really, really big play. Obviously, the Stargate cluster that Microsoft and OpenAI are co-designing and going to be building, this is a $100 billion compute cluster set to come online in 2028. That gets a lot featured quite prominently in this report as an instance of saying, hey, you know what? These companies internally seem to believe that this is a live proposition. So it's just really interesting. And you're seeing, anyway, all the fascinating machinations of how companies are acquiring more power to fuel these insane training runs. Amazon, having this almost 1 gigawatt nuclear power contract in Pennsylvania that they've locked in on. The Microsoft OpenAI campus apparently is a 5 gigawatt cluster that they're teeing up. So, we're getting up there already in terms of what's being planned for. And that's not even 2030. Like we're talking about 2028 there. So, things are crazy, at least in terms of the investment. We'll see if the payoff is there. But if it is, you got to figure there's a reason Microsoft is investing, whatever it is, like, 6 Airbnbs every 4 years into building data centers. They think that there's going to be something there for them.
Right. And I guess you'll have to start investing in power supply. I mean, just a national infrastructure question of this is already super interesting, right? And then you get into policy, and it's kind of a lot of crazy things to think about. But at least this is answering one of the questions of, just in terms of the physics, is it doable? And the answer is, so far, it seems to be doable. Next paper is Agent Q, Advanced Reasoning and Learning for Autonomous AI Agent. So we are talking here about going from just an LLM to an agentic kind of LLM. We've covered this before. LLMs are passive models in the sense you give them an output, they spit out, you give them an input, they spit out an output, and that's it. Agents are able to take in a request and then go off and independently do some work, some series of steps to hopefully accomplish whatever you need them to accomplish without you being aware or supervising them the whole way. And this is a new work of research from the AGI company, Motion, with some collaboration with Stanford, that proposes one possible agent architecture that leverages LLMs. In particular, they have a framework that combines guided Monte Carlo tree search. Combining basically search, where search is you think one step ahead, you think 2 steps ahead, you think about different possible branches, and eventually it's basically planning ahead is search, right? And then combining that with self-critique and iterative fine-tuning on agent interactions. So you can essentially learn as you go. You do something, you try it, you give yourself a reward. Did I succeed? Did I not succeed? And then you do direct preference optimization, basically what we already do with alignment, saying, okay, I did the right thing or I didn't do the right thing. Let me improve my own capacity to do things properly. So they combine all these things into a framework that you can use with an LLM like Llama or like ChatGPT, and then apply it to one of these kind of demo cases for agents. In particular, here they have a simulated e-commerce platform where they want the agent to go and book you something or buy some thing related to searching and acquiring something. So numerically, they say in a real world booking scenario, their methodology boosts Llama 3 70 billion zero shot from 18.6 success rate to 81.7 success rate. So they take the base model, they plug that model into this framework, and it can then perform much, much better. And this is after a single day of data collection, and it can even improve with some online search. So one of quite a few of these, there's been quite a bit of work on the idea of an architecture of a framework such that you can plug in an LLM and get out an agent. And this is, seemingly a pretty impressive idea, and combining a few important aspects of agents in terms of planning and in terms of continual learning.
Yeah, absolutely. I think one of the big conceptual leaps here, right, is it has us go from thinking of training as something that applies to language models. So you train your language model to do next word prediction, and then you have this model that has, well, a good world model. It understands a lot of stuff, and then you kind of you kind of get it to to break down a problem, let's say, into substeps, and then execute those substeps. And it just happens to be good at reasonably good, that is, sometimes at executing on those steps because of its sort of pre-existing world knowledge that it gained through that next word prediction training. But there's obviously no reason that next word prediction training should make for a particularly good agent. It's just kind of happenstance. It's coincidence, right? So what they're doing here is saying, no, we're going to architect an agent, and then we're actually going to train. We're going to update the model's weights based on how it performs at these agenty tasks. And so that kind of starts to get you more in the direction of like, okay, we're fine-tuning for agent-like behavior. And this is something that, when you think about GPT-5 and what's going to make it different, like agent-first architectures are now going to be a thing. This is a bit of that kind of flavor, and a really, really big capability leap, right? You mentioned, under 20% to over 80%, thanks to this framework, thanks to this strategy. I think there's a lot of stuff like that out there. I don't think, even if you froze progress at the frontier, I think you would find significant capability leaps, especially on agentic tasks, that are already baked in just by virtue of the fact that we have out in the open source today, the stuff that we have out in the open source today, just by virtue of the fact that people are going to find cheap ways to fine-tune these models to do extraordinary things. One of the things I found really interesting about this paper, they make the argument that really they're drawing from Richard Sutton's famous essay, The Bitter Lesson, which is basically this idea that if you look at the long arc of machine learning history, which I guess is actually a short arc, the techniques that tend to work really well are the ones that just are really good at leveraging highly scaled computation. So they're not customized. They're not the techniques that like human beings sit around a table thinking really hard at and come up with a brilliant idea. No, the techniques that work best, the claim is, are these general purpose techniques that are just really good at funneling gigantic quantities of compute to solve a certain task. And the thing you're betting on when you do that is that compute is just going to get cheaper and cheaper and cheaper. So eventually, no matter how clever you get on the front end, you're going to be defeated by some algorithm that just is good at leveraging huge amounts of compute. And that's really what deep learning models are said to be. So in this case, that's kind of the whole point, right? They're setting things up such that the cheaper compute gets, the more you're able to train this agent, the more you're able to refine its behavior for agent-like behavior specifically. And it's all based on the same kind of approach, or an approach that's philosophically pretty similar to the kind of AlphaGo type stuff. They've got the sort of Monte Carlo tree search type approach where basically you confront the agent with a website, you give the HTML code of the website, it reads it, and then it proposes a whole bunch of next actions that it could take. And then you've got a process where it reflects and figures out, okay, like which of those through lines am I going to pursue? So it tries to pursue that, and then it sees where it ends up. And then it's able to evaluate, okay, in retrospect, what was my decision-making process like? Was that a good decision-making process? And you can kind of repeat this at every node, working your way down the tree, and ultimately you end up with, well, this tree, which is exactly what you see with the kind of AlphaGo type models. So, this is not a coincidence. You're going to see more and more of this every time I talk to friends at the Frontier Labs when they're looking at, what's the next beat. It really is this sort of reasoning. Monte Carlo tree search is a big facet of that, and not in some ways not surprising to see this sort of thing, but impressive as hell to see it working so well so soon.
Yeah, and it really is a trend of this year, right? It's one of these things where you're seeing in practice text to video, music generation, things like that, like behind the scenes in published papers or in conversations between academics and so on, agentification, making LLMs into agents is one of the big trends. And I think in large part that's because it seems that most people have a sense that with the current models, with GPT-4, Llama 3.1, the LLMs are strong enough, and what is missing is that kind of agent architecture that allows it to be recurrent, ongoing, have memory, have exploration, and online learning or learning from experiences, which is one of the weak points of LLMs. And yeah, personally, I am on that train. I think this kind of thing is probably all that's needed, and people are very much working on figuring out the right set of tricks to make this usable and reliable. And in lightning round, the first paper is Transformers to SSMs, Distilling Quadratic Knowledge to Subquadratic Models. And the gist is that quadratic models are transformers, subquadratic models are SSM, state space models, aka Jamba, and similar models. And they show how you can take a transformer and then convert it to a state space model like Jamba. So you can take 5.5, for instance, and create Fire Jamba that is smaller, and also create a hybrid version. And so you can essentially get a Jamba type model for free. And one of the challenges with the current architectures, including Jamba, including SSMs in general, is it's harder to train because of the issues with parallelization that you get with recurrence, as opposed to just the quadratic, like I look at everything at every time step you have in transformers. So you get a lot of benefit if you can kind of spend a lot of money training something and then distill it into an SSM, as they do here. Yeah, seems, as you might expect, the results point to it working really well and this being a pretty promising approach.
Yeah, I thought this was just such an interesting paper. And the way conceptually it works is they'll identify, like, imagine that you start off with some sort of transformer model, right? And you want to turn it into a Jamba model. Well, you'll take a look at so that model is going to be made of a bunch of transformer blocks, as they're called, right? So you subdivide your transformer into a bunch of repeating transformer blocks. And in those blocks, there is a certain matrix transformation, a self-attention matrix, that does, well, all the kind of self-attention work, essentially attending to all the other tokens in the input sequence to determine what the next token should be. And what you're going to do is you're basically going to say, okay, in Jamba, the equivalent roughly to the self-attention matrix is the SSM matrix, right? So what you're going to do is you're going to say, okay, let me just look at just this one self-attention matrix and this one SSM matrix. So the self-attention matrix in the transformer that I've got, and then the SSM matrix in the model I want to train. I'm basically just going to take that transformer that I start with, and I'm going to replace the self-attention matrix with an SSM matrix that's not yet trained. And I'm going to now kind of train the rest of the model is identical. So you've just got this one little bit, the SSM bit, and you're going to try to train the model such that that SSM matrix generates outputs that match what the original self-attention matrix in the transformer did. So just that one little bit of model, you're going to try to train the model overall to kind of the rest of the model is identical. So you got this very controlled retraining of just a small part of the model. And that's key because the self-attention matrix is the part of the transformer that is quadratic in compute requirements. And so by replacing with that SSM, that's kind of the meat of the operation. Once you can get the SSM to output the same stuff as just that self-attention matrix, that's pretty cheap. Now what you do is you say, okay, now let's continue the training at the block level. So now let's get the blocks overall to output the same stuff with more fine tuning. And then you do the same thing at the model level. So you're kind of progressively zooming out more and more, just kind of, I don't know what that game is, Jenga or whatever. You pull out piece of wood and you try to make sure that the structure is still stable. It's the same idea here. Really kind of make your initial core modification, just that crucial SSM matrix that you're going to swap in for the self-attention matrix. And then the rest is just like, okay, now let's fine tune it so it behaves the same. Let's zoom out, fine tune the blocks so they behave the same, and then fine tune the whole model. And this is, it's really, I think conceptually, it sounds simple, like, or at least it's one of these ideas, again, I keep saying this, but back in my physics days, like it was ideas that seemed the simplest where you're like, oh man, that's a really good idea. And that tend to work out the best. So they get a whole bunch of impressive results. It turns out you can, in this case, they distill the model with just 3 billion tokens. That's less than 1% of the data that was used to train the previous best performing Mamba models. And it was just 2% of the data that was used to train the original Phi 1.5 model, the transformer they were starting from. So Andre, to your point, much harder to scale up training of Mamba models. There are a whole bunch of hardware reasons why that's the case. But ultimately what this allows you to do is say, okay, well, let me train the thing that I can train scalably, the transformer, and then just leverage that to get a really performant Mamba model. And the crazy thing about this, like I've often talked about my tendency to believe in what's known as the hardware lottery, which is this idea that, hey, transformers, they may not technically be better than Mamba or other architectures, but there's so much hardware optimization, software optimization that's pointed in that direction that it's kind of over. Like, people are going to keep investing more and more in transformers. They'll get more and more efficient. Doesn't mean that other models don't in principle have more potential, but here we are. This is a way around that, right? If you can start to kind of transfer over effectively to another platform, another architecture for a low cost of like 1% or 2% of the training data, now you're kind of in business. And that's what's really interesting about this paper. I think it's a really strategic paper, if you will.
Right, exactly. And to just jump in a bit on the details of the performance, they have a table comparing their Phi Mamba 1.5b to essentially all the other variants of this idea of state space models, and also some other smaller models. So they compare it to Mamba 1 1.4b, Mamba 2 1.3b, XLSTM 1.4, PyPhi, et cetera, And on this Phi Mamba 1.5b, that, as you said, they used only 3 billion tokens, a relatively small amount, they get the best performance on pretty much most benchmarks relative to all these other models, despite using much less data. And they get close to matching the initial 1.5, 1.3 model. So we're not quite at the same level as transformers, but we are by far the closest of any of these other small state space model type architectures. So to me, it's one of these, like, it seems intuitive and kind of straightforward to imagine, well, you can train really big transformers. Why not just like take that and convert them to these things that are efficient at inference time and scale better at inference time? But at least I haven't seen a paper do that until this one, and the results are pretty exciting. So could be kind of impactful. We'll see.
And up next, we have loss of plasticity in deep continual learning. And I'm going to highlight that this paper is co-authored by Richard Sutton. So this is the real deal, folks. It's one of the godfather of reinforcement learning, Rich Sutton. So, okay, what is loss of plasticity? It turns out that if you start by training a model on one problem space, one type of problem, and then you train it on a different type of problem, and then on a different type of problem, and then on a different type of problem, in that order, eventually you'll find that your model is going to get worse and worse and worse at learning the new problem spaces. Okay, so in a way, it kind of feels like this other phenomenon called catastrophic forgetting, but it is different. In catastrophic forgetting, what ends up happening is you train a model on more and more stuff, and eventually starts to forget the stuff that you trained it on before. Right? It treadmills out the old knowledge. So this is instead a question of how quickly the model is going to learn to solve problems in a new problem space, in a kind of new distribution, to use the language, right? So the way they set this up is it's an investigation of this phenomenon and a bunch of suggestions as to how you might mitigate this problem. And they start with this data set called ImageNet, the famous ImageNet data set. Basically, this is like 1,000 different categories of images, and they're all labeled. It's cats, it's dogs, it's airplanes, it's school buses. And what they're going to do is they'll say, okay, we're going to take these 1,000 categories. And usually the problem that you give to your model is you say, okay, I'm giving you an image. Tell me which of these 1,000 categories it belongs to. But they're going to change the frame here. And instead, they're going to look at every pair of categories. So you got 1,000 categories. You can have 1,000,000 pairs of categories. So for example, a pair would be like dogs and cats. And you're going to, in each case, train the model to just distinguish the two. Distinguish images of dogs from images of cats from images of sandwiches, and so on and so forth. And what they're going to do is they're going to train the model on one of these pairs. So get it really good at telling cats apart from dogs. And then get it really good at telling toilets apart from wrenches. And repeat and repeat and repeat with more and more of these problem spaces, these subspaces. And over time, what they're going to do is they're going to measure how much data it takes to get the model to perform well on the marginal next problem. And what they find is, well, loss of plasticity. The model starts to struggle more and more as you give it more and more of these tasks to perform. And they end up proposing a strategy to mitigate this. It's actually quite interesting. When you read the paper, they don't get too deep into trying to interpret why this is happening. That seems to be a bit of an open question to them. Yet they still find these mitigations that work pretty well. So what they'll do is they'll reinitialize a small number of the neurons basically in the model, the neurons that let's say are least involved in generating correct outputs. So they'll just say, you know what, this one doesn't seem to be being used much, so I'm just going to zero it out and kind of retrain that neuron from scratch. And then they'll do this with kind of a very small fraction of the weights in the model. And they find that leads to a kind of better plasticity, a sort of refreshing. I mean, I guess the metaphor is sort of like, what if you could just regrow from scratch some of the neurons in your brain every once in a while to kind of keep you fresh? That seems to be working pretty well in this paper. So this is very interesting. It's highly empirical, and it is reflective of a kind of approach to this problem space that Rich Sutton has, because he's so focused on reinforcement learning. And they do, by the way, they don't just look at images. They have a reinforcement learning setting as well. It's just a little bit more complex. But the bottom line is, this problem seems to keep reemerging, which is why Rich Sutton is so interested in kind of doubling down on solving this. He is the kind of OG AI scaling guru, right? Like, this is the guy who flagged with his famous blog post this idea that scale matters. And here he is kind of identifying one of the key challenges that comes with that. So thought really interesting paper, and felt a bit almost Yann LeCunish in the way that it identifies a very conceptually simple problem that current models still do have.
Yeah, I agree. It's quite an interesting paper, partially because we know about catastrophic forgetting. That's like the thing that everyone knows is, as you try to train a model on new tasks or new information, you will probably lose the information that you had previously learned on. And what this is showing is actually distinct from that. It's saying, as you train on a procession of tasks that are all of similar difficulty, or actually the same difficulty, it's not saying, can you still do a thing you could do, 3 tasks ago? It's saying, can you learn this new task as well as you could the previous n tasks? And so this observation that somehow, as you learn more and more, you are worse at learning that when you were at the start, when you hadn't known any skills at all, that's very novel in this case. And this is, to be fair, just so you know, on a sort of toy-ish task. It's a procession of like classification between 2 images. So it's on more on the theory side, you could argue, at this stage, but still very interesting.
But it is interesting for how it interacts with this notion of sample efficient learning that you get at scale, right? So as you scale models more and more, it turns out paradoxically and seemingly contrary to the results of this paper, it turns out that the model will learn the marginal next task much faster. You see this with language models all the time, right? Where, you train the model all in English and it takes you a gigantic amount of tokens to do that. And then for a fraction of that token count, like 1%, 0.5%, the model will then learn a new language crazy fast. And I think there's something really interesting going on here. This is kind of a half-baked thought, and they don't try to address this in the paper. And I'm really interested. I'd be interested in the author's take on what the distinction is. But I think there's something very interesting going on in terms of what you define as one problem space versus another. The extent to which they overlap, I think, is playing an important role here. That's my intuition, at least. But I'm really this is a space I'd be really curious to see more deep dives into for sure.
Yeah, I mean, I would say my intuition as well is, the distribution's got to overlap or else you're no good. But I guess we'll see probably in future research. On to policy and safety. And the first paper is once again about SB 1047, California bill on AI regulation that we've been covering quite a bit, has been the hot topic lately. And the news is that the bill has been weakened with regards to AI disasters before the final vote. So it has been amended in such a way that there's less power granted to the government in holding AI labs accountable in this case. It doesn't allow the Attorney General to sue AI companies for negligent safety practices before a disaster occurs, which is something I believe you covered Anthropic had in their opposition to this bill. They were skeptical of the idea of kind of regulating how labs prepare for these sorts of things. The bill also will no longer create a new government agency called the Frontier Model Division, but will have a board of frontier models. And there's a few more things. Also, AI labs are no longer required to submit certifications of safety test results under penalty of injury, but there are going to be public statements. Lots of these amendments that basically require less of companies like Anthropic and OpenAI. So perhaps not surprising given the very, very, very significant pushback from companies in California. And I think one thing that in particular Meta will be happy about is the bill does protect open sourced fine-tuned models, saying that if someone spends less than 10 million fine-tuning a model, they're not considered a developer under this bill. So if you take a big model and then fine-tune it to your own spec, you're not under the same restrictions as Meta training Llama 3, for instance. So quite a big change, it seems to me, and does address some of the things that critics have put forward as issues with the bill. We'll see probably a lot of the people opposed to it are still opposed to it, but definitely notable difference.
Yeah, absolutely. I think, one of the things that's not often talked about in the context of the bill is just how rarefied the set of players is who would actually have to abide by the regulation. It's, if you're training models that are $100 million plus in cost, then it applies to you. Right. So there's been a lot of noise, especially from OpenAI, coming out and saying, this poses a regulatory burden. It's bad for innovation, blah, blah, blah. But the actual requirements, when you look at the bill, apart from being bloody similar to a lot of the things that OpenAI had previously committed to doing voluntarily, not entirely, right? There are nuances. But it looks an awful lot like the voluntary commitments that they've made. And now we're hearing all this pushback on, stifle innovation in a context where it's like, yeah, if it's $100 million, but like if you have the resources to build that kind of a model, yeah, you arguably have the resources to submit to some regulation here. But in any case, this has been a really interesting saga. Anthropic did come out with objections to the initial bill. A lot of those objections, a good chunk of them, have been addressed in this bill, not all. And Anthropic's come out with a statement themselves. This is from supposedly Dario Amodei, but I will say it reads as if it was written perhaps by Jack Clark, who heads up policy there. So it was quite interesting. They basically say, in our assessment, the new SB 1047 is substantially improved to the point where we believe its benefits likely outweigh its costs. They do go on to say they're not sure about that, but that reads pretty well as like a tepid endorsement, which does track. They got some of the things they wanted, not all, and so a qualified endorsement I think makes a lot of sense on that basis. They said they highlighted the risk of government overreach if this is signed into law. One of the big things they're trying to do is maintain, as they put it, a laser focus on catastrophic risks and resist the temptation to commandeer the bill to accomplish unrelated goals. So that kind of makes sense. One of the things that's been changed is, this risk of criminal penalties being incurred by developers for intentionally submitting false information about their safety plans to the government under penalty of perjury. I mean, I gotta say, I'm a techie guy. I don't like regulation, but if you're gonna lie intentionally, submit false information about your safety plans to the government, I think criminal penalties, I think the average American would look at that and be like, any other industry, if freaking Boeing is submitting intentionally false information about their safety plans, criminal charges should probably apply, but that's been taken out of the bill, just to give you an idea of where the decision surface is being drawn there. But in any case, they say it seems like a feasible compliance burden. No surprise there, obviously, given the costs associated with it. There is one thing I want to call out in this write-up, this letter that Anthropic put together, because it gives us a sense of their core thesis. They say, in grappling with essentially the regulatory dilemma, they say they've come to the view that the best solution is to have a regulatory framework that is very adaptable to rapid change in the field. They say there's several ways to accomplish this, blah, blah, blah. Down the road, they say, perhaps in as little as 2 to 3 years, when best practices are better established, a prescriptive framework could make more sense. And they point to automobiles and aerospace as being industries where that's happened. But they also say that, as noted earlier in the letter, we believe AI systems are going to develop powerful capabilities in domains like cyber and bio, which could be misused, potentially in as little as 1 to 3 years. And they say, in theory, these issues relate to national security and might be best handled at the federal level. Okay, that's interesting. In theory, they're saying this bill really should be a federal level bill, but they say in practice, we're concerned that congressional action simply will not occur in the necessary window of time. Now, I will invite you, finally, to contrast that with OpenAI's statement, which is basically, hey, we don't think it's appropriate for this to be done at the state level, should be done at the federal level. Again, that makes sense in theory, but OpenAI knows. They know. I can tell you firsthand, they've got lobbyists on Capitol Hill. We often walk into congressional offices shortly after the OpenAI lobbyists have left, and they know just as well as anyone that action on Capitol Hill on this is not likely to happen anytime soon. And so, frankly, it becomes challenging to take, particularly as good faith, an assertion like, oh, well, this should be done at the federal level. Yeah, you could see it certainly as an attempt to just stonewall and play a delaying action. So anyway, long-winded way of saying there are very different takes on this. OpenAI whistleblowers also came out, by the way, with this open letter, basically calling out OpenAI for what they frame as a kind of hypocrisy, saying that their former boss, Sam Altman, has repeatedly called for AI regulation, and they're saying now, when actual regulation's on the table, he opposes it. Anyway, lots of drama going on here, but it's interesting to see the contrast starting to form now on policy more explicitly between OpenAI and Anthropic.
Yeah, the drama is, as ever, present here. A little more technical now. The drama is, I guess, substantial related to policy. As you said, there was this letter from OpenAI whistleblowers released on August 22nd, directed to Governor Newsom and the Senate President Pro and Assembly Speaker regarding this talking primarily about OpenAI and its, disagreements with the paper. To be extra clear, the paper had these amendments before actually passing through California's Appropriations Committee, which is a major step to becoming a law. So next, it will be heading to California's Assembly floor for a final vote. If it passes, it will then go back to California's Senate for a vote due to these amendments. And then if that passes, it will go to Governor Newsom, the Democratic governor of California, who will either veto it or sign it into law. So still could be some developments in the case. It's been one of the, I guess, main movements in AI policy in the US so far, ever since the executive order of Biden. So pretty significant to cover. I will just mention, I didn't mention this at the beginning, but we had another negative review regarding needing less doom, and it did call us SB1047 cheerleading, which I think is like the most boring topic to cheerlead ever.
Yeah, that's true.
On record, I work in industry, so obviously I cannot cheerlead this bill, because who in industry would like to be regulated? Come on.
Yeah, other than, I guess, apparently Anthropic, but yeah.
And next up, we have a bit more of a paper. It's titled Personhood Credentials, Artificial Intelligence and the Value of Privacy-Preserving Tools to Distinguish Who is Real Online. So it's basically making the point that as we get into significantly advanced AI, it's going to be very difficult to tell whether you're interacting with an AI or with a person. It already is to some extent, right? With chatbots can be pretty effective. It can be even more of a case once you can do real-time audio and video. So this is analyzing the value of the so-called personhood credentials, which are digital credentials that basically prove you are a real person, not an AI, to online services, but without disclosing who you are to the service. And the idea would be that these credentials would be issued by trusted institutions like governments, can be local, global, etc. And yeah, it's a very long, I guess, analysis of this. So it's not necessarily going to lead to implementation per se, but makes a case for this being useful.
Yeah, I thought the paper was like 60 pages long, and I kept feeling like it was going in circles a little bit and like kind of re-explaining the same stuff that it explained before. But still, nonetheless, I do think the idea makes a lot of sense. There's a whole bunch of thinking in the paper, by the way, about this idea of like, you don't want to have a government that has too much leverage over deciding who can and can't access certain platforms, this and that. Like, how do you reduce the risks associated with having, for example, a single centralized issuer of these credentials? And I think that's actually a really good thing. Again, as a kind of tech guy, free market dude, I like that idea. I like the idea of really trying to find a way that, because the big challenge, right? This is going back many years. When you look at Twitter, the obvious solution to bots is to force everybody to like freaking show you their passport or something insane like that before they create an account. Right? That's the way you would do it. Now, that's bad for so many reasons. You don't like anonymity on Twitter, makes it so that people in Saudi Arabia can come forward and criticize the government publicly, right? It makes it possible to do a lot of important things. So we want to try to preserve that as much as we possibly can. And turning to government, like, are you really going to trust government to kind of issue these credentials in a way that is going to be democratic and free? Most importantly, some people might suggest the answer is probably no, and I would definitely sort of agree with that skepticism. So essentially, this is all about techniques that you could use to have multiple issuers of these credentials from multiple services that would allow you to do this stuff without. It's not like you're giving your social security number or whatever when you're signing up. You have distinct credentials for each platform. It's just so they can confirm that there's one personhood credential to one person. And that way you prevent the bot account issue and all that stuff from accumulating. So interesting paper. It doesn't get into the technical side of like, or the cryptography side of it as much as I might have been interested in seeing it, but it kind of makes sense because it's like it's an initial thought piece exploring the system side of how this might all work. So really interesting, especially crucial, as they point out, given the agentic AI users that are going to be on the internet very soon, that already are really, but they're going to dominate more and more of the internet. We're just going to need a way to tell who's human and who's not. And this kind of thing, it relies on the fact that the one thing AIs can't do and may not be able to do for a little bit of time at least is mimic a human in the real world. Right. They're not yet there yet. And so we can rely on the fact that humans can be asked to go in to kind of confirm physically their identity. Once that happens, you can rely on cryptographic protocols to do the rest of the work and associate that once verified identity to a whole bunch of other kind of verified accounts on various platforms. So there you have it.
And next, another technical work, this one dealing with interpretability. And the title is Showing SAE Latents Are Not Atomic Using Meta-SAEs. So an SAE is a sparse autoencoder, and that is a way in which you can understand how a large language model works. So what you do is you feed a large language model some data, you let that data propagate from input to output, and you get a bunch of intermediate outputs. And then you can take the intermediate output and basically train another model that compresses it. So you compress the outputs at some layer, and what you end up getting when you compress it is what people call a dictionary of features. So you can tell within the crazy big set of intermediate outputs that you get, there are these patterns of activation where a certain feature might relate to German, and another feature might relate to questions, and another one might be coding, etc. And when you do that, it becomes very useful to explaining the behavior of your model, because you can then attribute, behavior to certain intermediate outputs, and you can even affect how a model performs. And so what this paper is doing is exploring the question of when you do this training, are the features you get, the dictionary you get, in fact, sort of the base level of a so-called atomic, in the sense that they cannot be further divided, and they're the base layer. And they argue that that is not the case, that you can take a sparse autoencoder and then you can train another sparse autoencoder on top of it, resulting in a meta sparse autoencoder. And that sparse autoencoder then splits up the features more, roughly speaking. So that is the main conclusion of the paper. It has a fair number of discussion of kind of the nature of sparse autoencoders in general, and I think deals more with the sort of, hypotheses of people with regards to what is it that you get when you train a sparse autoencoder.
Yeah, I thought this paper was really interesting. As I think you mentioned, Anthropic in particular has been really big into using SAEs, these sparse autoencoders, to do interpretability on very large models. Their concern is about all kinds of things, including this concept of deceptive alignment, where you might have models that pretend to be aligned, that pretend because they know they're being evaluated, they know they're being assessed, they pretend to generate outputs that are safe and blah, 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 and pretend to be well-behaved, but actually aren't. And the hope is you can use techniques like this, interpretability techniques, to understand when that sort of thing is happening. And the setup here, again, the kind of SAE setup is pretty crucial. The way this works, to take another analogy, right? You talked about these intermediate outputs that show up in the model when it's processing its inputs. In your brain, when you consume some kind of input, your neurons will get activated, right? Different neurons will flash and get activated and so on. And so that pattern of activation is what you're going to feed into your sparse autoencoder. You're going to try to take that in, force that pattern of activations to be represented using a small number of numbers. Okay, you're going to try to compress it down to a small list of numbers and then reconstruct the pattern of activations based on that small set of numbers. So you need to have, essentially, you're going to try to minimize the reconstruction error. So you're going to encode those activations and decode them, encode them and decode them. And over time, you're going to get really good at doing that compression. And the hope is that the small list of numbers that you're hiding all that complexity in, that you're compressing that complexity down to, is going to be interpretable. That basically when I look at one of those numbers, that number will be associated with a human interpretable concept, like a box or the color red, right? So a certain pattern of activations might then be revealed through this list of numbers to be associated with an encoding that tells you, the model is thinking about the color red, something like that. And what they find in practice is that if that list of numbers that you use to encode all the activations in your neuron, if that list is too long, then there's going to be a lot of redundancy in what that list holds. So you'll have like red box in there and like blue box. And those two concepts are actually quite similar. They're related by the concept of a box. But instead of having just the concept of a box and then separately the concept of a color, they'll get merged together because if your list is long enough, you can afford to use a bunch of those entries to be lazy about it and not actually bother thinking about, is this truly an atomic concept? And so they'll essentially repeat this process and use another SAE on top of the first one to run the same process again, but have a smaller list of numbers that they're forcing things to get compressed down to. And by doing that, they're able to force these abstractions that are being captured in that list of numbers to be more atomic and kind of control the resolution of atomicity of these concepts in a way that, gives you more control over the degree of interpretability. So I thought this was a super interesting paper conceptually. Again, very simple idea, but it results in something that could have meaningful implications for alignment and safety.
And just a couple stories in synthetic media and art before we close out. The first one is authors sue Claude AI chatbot creator Anthropic for copyright infringement. So this is a class action lawsuit by authors Andrea Bartz, Charles Graeber, and Kirk Wallace Johnson. And it is similar to lawsuits that have already been filed against OpenAI. I believe the first one against Anthropic in this case, and is again making the case that Anthropic trained on these authors' data, and therefore this is copyright infringement, and they should be compensated, added to the stack of lawsuits that are ongoing.
Yeah, first one, I guess, for Anthropic. So I guess that's a change. Their war chest is going to be smaller than OpenAI's too, so maybe can't afford to buy the same licenses to license their way out of it. But we'll see.
And the last story, also dealing with a lawsuit, it is that the artist's lawsuit against Stability AI and Midjourney gets more punch. So this is saying that Judge William Orrick did allow for a direct copyright infringement complaint against these companies, but had dismissed other claims asking for more detail. Now, in a more recent ruling, the judge approved an additional claim of induced copyright infringement against Stability and allowed copyright claims against DeviantArt and Runway AI, which used models based on Stable Diffusion. And also allowed copyright and trademark infringement claims against Midjourney. And the company had this Midjourney style list of 4,700 artists whose name could be used to generate works in their style without the knowledge or approval of those artists. So some progress there. The judge did dismiss claims about the Digital Millennium Copyright Act with regards to altering copyright management. But still, it's moving forward clearly, and there's a bit more clarity on the contours of the case.
Yeah, and interesting that notion of induced copyright infringement being a particular problem for AI. So apparently the definition of induced infringement, #not a lawyer, is if you've got a company that, for example, provides instructions for using their product in a way that violates a copyright or something like that, then that can be induced copyright infringement. And you can imagine how that might apply to models that, when prompted, can generate copyrighted material. Andre, you're talking about earlier today. I forget what it was, Sonic the Hedgehog or whatever, or Mario. You give it like an Italian plumber who's blah blah blah, and then it'll generate an image of Mario. That's an interesting case potentially for induced copyright infringement. So I guess we'll be seeing more of that.
And with that, thank you so much for listening to this episode. We are finished. And as always, you can go to lastweekend.ai to subscribe to the text newsletter. You also get emails with each podcast, including those links to the articles and papers. So that's another way to get to the links. As always, please do subscribe, please share the podcast, and please give us any corrections, any suggestions, and any 5-star reviews, and even 1-star reviews if you really feel we deserve it. You can give us a 1-star, although I think that's a little harsh.
And I will say, true, it would be, you could argue a little harsh, but still, fair is fair. I will say also, in case I am fortunate enough to have a baby in the family, at the end of the week or something like that, I just want to say, I'll see you guys, I guess in a couple weeks when I'm back from my pat leave. But go AI world in the meantime.
We will not make you host a podcast with a baby, that's for sure.
On lack of sleep. Yeah, that'd be great.
Alrighty.
Welcome back, it's episode 180. Last week in AI, the news is never shady. Ideogram V2 drawing visions, not just maybe. Dream Machine 1.5, can't deny it's getting crazy. Jamba's on the rise, blending tech like Dracarys. AI in 2030 visions where we're gonna be. Futures here, the Banter in the mix, fitting fire updates. Episode 180 kicks, Ideogram V2, seeing clear through the fog. Dream Machine 1.5, jogging minds like a log. Jamba's mixing minutes, tech twist like plot fizz. AI in 2030, where the future about to glitch. Stay buckled, stay tuned. The intel ain't dull. It's last week in AI, where we keep you on the pulse. Policy papers drop, ain't no registered debate. Governments grappling, can they legislate fate? For government to the states, frameworks start to lace. In this tech race, every move's got an ace. With tools on the rise, video creation's clean. It lives its life like it's a strange dream scene. Welcome to the show, it's last week in AI, where we take you high, beyond the cloudy sky. Episode 180, let the data fly. Brainwaves connecting, updates in the ether. Open source surge, AI coming like the fever. Versions drop fast, tech moves like a mind reader. Personhood debates, credentials growing deeper. Now the buzz is real, models keep improving. Episode 180, energy's grooving. Transformers gains, the advancements ain't losing in the AI realm. You see us always cruising.